Today we're going to look at 1.4 and 1.5, literal equations and application problems. So we're going to start with rewriting equations. We're going to start with a perimeter equation. So it's P is equal to 2L plus 2W. And our job is going to be to solve for W. So this is the type of problem where they give you a problem that has all variables in it, and then your job is to isolate one of the variables. So my job in this problem is to isolate this W. So I want to move everything away from the W. So again, remember you always move addition or subtraction first. So I'm going to subtract away 2L from both sides. Usually you make like a cursive L whenever you write an L so it doesn't look like a 1, or you can use a capital L. So I'm going to have P minus 2L. They're not like terms, so I just write them together like that, equals 2W. So now I ask myself, how is the 2 connected to W? And I answer multiplication. Therefore, the opposite is to divide. So divide both sides by 2, and I usually just leave it all over 2, but you could separate it if you wanted to. We'll go ahead and leave it like this, is equal to W. The other appropriate answer for this problem would be P over 2 minus 2L over 2, which would be 1L, equals W. So those are both okay. This one is the simplest since we're just starting on this part. Alright, next we're going to have a problem like this. This is actually a problem that's in standard form, and we're going to solve it for y. So we're going to put it into slope-intercept form. So the first job again is to isolate the variable. Since we want to solve this for y, we're going to isolate y. So we always want to get away anything that's being added or subtracted to y, and so that would be the 10x. So we're going to minus 10x minus 10x. So that'll leave us with negative 18y is equal to negative 10x plus 84. So now again our job is to isolate y. The negative 18 is connected to y by multiplication, so we're going to divide both sides. Everybody gets divided by negative 18. So since the number in front of y is negative, it's a lot easier just to go ahead and divide by a negative, and that way we get a positive y. We don't have to worry about any negatives. So here, a negative 10 divided by a negative 18 is positive, and then 10 over 18 reduces to 5/9. So I'm going to have 5/9 x, and then minus, because a positive and a negative makes a negative, and then 84 and 18, I'm going to divide them both by 2 and see where that gets me. So this would be 42 over 9, and they don't have anything in common. Oh no, they have a 3 in common. So we have to divide the 42 by 3. So that'd be 1, 3, 12. And divide that by 3. Alright, so we're going to take a problem here that's in slope-intercept form, in standard form, and turn it into slope-intercept form. So if we look at this problem, our job is to isolate the y. So we want to get y by itself, so we're going to get rid of the adding and subtracting part. So we're going to get rid of minus 10x to both sides of the equation. So we're going to end up with negative 18y equals negative 10x plus 84. Then we go back to the y. So it's not quite by itself. 18 is still being multiplied by it, so the opposite is a divide. And since it's a negative 18, I'm going to make sure to divide everybody by negative 18. So I'm going to have positive y equals, because negative 18 divided by negative 18 is positive 1. A negative divided by a negative will be a positive. And 10 over 18 reduces to 5/9 x, and then a positive divided by a negative is negative. 84 and 18 makes, so divide them by 2 and you're going to get 42/9, and 3 goes into that again, so 14/3 is what it reduces to. And leave your answers like this in like the 14/3 in improper form, and make sure that the slope is always a fraction. In this case it's a regular fraction, but never change it into a mixed number. So we just leave them as 2 fractions or an improper fraction. Alright, so on this next step we're going to be looking for a pattern. So I'm going to give you a table, like a function table, and then we're going to look for a pattern inside that function table. So for example, we're going to have like x and y, and when x is 0, y is 11. When x is 1, y is 15. X is 2, y is 19. 3 is 23. So on these problems, we're looking basically for the rate of change. So how is x changing is how we start this problem. We see that x is increasing by 1. So x increases by 1. And how does y change? Y, if we look at the difference between each of these, y is increasing by 4. So that's the rate of change, which conveniently enough is the slope. And slope is equal to the change in y over the change in x. So that would be the change of 4 over 1. And that gives us that pattern. And then the second part is to write an equation for this. So this is our slope. Do you see where we got this from? This was the change in y over the change in x. So the equation is y equals mx plus b. Right, that's the equation for slope. So y equals, this is the slope, 4x, right, the slope, the rate of change, plus the intercept. Remember that the intercept is when x is 0, what is y? So that's 11. So our equation is y equals 4x plus 11. All right, we're going to look at another one of those. So we're going to do x over y. So we're going to have 0 and 46, 1 and 36, 2 and 26, 3 and 16. So again, we are looking for the rate of change. How is x changing? What is the pattern? So x is increasing by 1. And what is y doing? So y is getting smaller. So y is decreasing. And is it decreasing by a constant rate? That's what we want to know. So we notice that the rate of change, the difference between each of them, is 10. So it's decreasing by 10. So in math, that means negative. So slope is equal to the change in y over the change in x. So decreasing 10 over increasing by 1. So if we go to y equals mx plus b, because again the goal is to write an equation, y equals, the rate of change goes first, and then x, and then we're looking for the constant. So we look to see when x is 0, what is y? So it's kind of a fun way to do those. A little bit of thinking involved there, which is always fun. All right, so now we have this rate of speed problem. So we have a speedometer that's broken, and I'm on Kellogg. So luckily there are blue mile markers every 0.2 of a mile. I'm currently at mile marker 221/8, which is at Webb Road. I time myself, and it takes me 11 seconds to get to mile marker 221/6. Do I need to worry about getting pulled over? So what we want to do is we want to figure out what the rate of change is. So if we look at this one, in order to go, I went 0.2 of a mile, right? Because from 221/8, which means 0.8 of that mile, to the 0.6 marker would be 0.2. So how many 0.2 are there in a mile? There's 5 of those. So I'm going to take the 11 seconds that it took me to get from 221/8 to 221/6. It took me 11 seconds. And there's 5 2/10. So that's going to make 55. So it should have taken me 55 seconds to get from one complete mile marker to the next complete mile marker. All right? So I want to know what my rate of speed is. So that's 55 seconds per 1 mile. Right? Well, miles, it's miles per hour, right? So I don't want seconds on top. I want miles on top. So I'm going to have to flip this over. So I want 1 mile per 55 seconds. Right? Because it's distance divided by speed. So I need to turn, the miles is fine, but I need to turn the seconds into hours. If you're talking about a speed limit, you're always talking about miles per hour, not miles per second. So I'm going to change the seconds into hours. So remember that it has to go in the place where it'll cross out. And there's 3,600 seconds in 1 hour. If I take 3,600 and divide it by 55, I get 65.45. And that's miles per hour. So do I need to worry about getting pulled over? The answer is yes, right? The speed limit there is 60. or maybe at Webb it might even be 40, so I'm really in trouble. So we need to make sure I need to either one, go get my speedometer fixed really quickly, or I need to slow down right away. And that's one of the ways that you would actually use the rate of speed problem, is to actually figure out how fast you're going. There's other ways to use it as well, or other reasons to use it, but that one's kind of fun. All right, so the last thing that we're going to do is you're going to take the practice assessment. So you'll click on the link that I've provided and take the little practice assessment. It is from 1-1 to 1-4 to kind of make sure that you're on track. All right, see you guys tomorrow.